Tuesday, January 24th. Okay, so that should hopefully be a review. So looking at our little triangle handout, right? Let's look. So what's going on here? These are the same triangle. So I'll circle this in green. These two triangles are the exact same. What's the difference there? What's the only difference between the top and the right triangle? Yeah, so the bottom one is in degrees, the top one is in radians, okay? All right. Likewise, these are the exact same triangle. The bottom one is in degrees and the top one is in radians, okay? All right. So let's look at this. Let's think about our angles here. If I have pi over 4, right? What would something like the sine of pi over 4 be? What would the sine of pi over 4 be? What is sine? What does the SO stand for in SOHCAHTOA? Opposite over hypotenuse, right? What's the length of that opposite side? 1. What's the length of the hypotenuse? Root 2, right? And then rationalizing that denominator, we'd get root 2. We'd multiply by root 2 over root 2. That would give us root 2 over 2. Okay, so that'd be sine of pi over 4. Cosine of pi over 4 would be what? So let's just look at this one. They're the exact same. Let's look at that bottom pi over 4 angle. What would the cosine of that angle be looking at this triangle? Got it? What is cosine? That's adjacent over hypotenuse here. It'd again be 1 over root 2, right? Okay. To rationalize that denominator, we have to multiply by root 2 over root 2. How are we feeling about this kind of problem? Are you feeling okay about it? You guys, so you might not be able to draw this from memory now, but in the future, do you think you guys could draw those triangles from memory and then say, look at the picture and just say, here, the cosine is this, the sine is this, the tangent is this? Yeah, okay. Right. What would the tangent of pi over 4 be? What would the tangent of pi over 4 be? So what's the opposite side? This is opposite over adjacent. What's the opposite side length? What's the adjacent? Yeah, 1 over 1 is just 1, right? So that gives me the sine and cosine and tangent of pi over 4, right? We could do the same thing over here with my pi over 3, my pi over 6, and my pi over 2. One thing we should write in here, what is a right angle? How many radians are in a right angle? It's going to be pi over 2. Pi over 2. If you take 90 degrees and you multiply it by pi over 180, you'll get pi over 2. Okay? So maybe write those in, okay? So do we feel, hopefully we feel a little bit, at least a little bit okay with those, okay? All right, take these, move them down here, okay? All right, so Allie Kaplan asked a really good question last period of how do we find the sine, cosine, and tangents of an angle like pi over 2. How do we do that, right? Because it has like, right, what would the adjacent side be? What would the opposite side be? That's kind of weird, right? Okay, so today we're going to talk about finding the sines, cosines, and tangents of angles that are bigger than 90 degrees. Okay, that's where the unit circle helps us. Okay, so here's how I'm going to do this. Here's how we're going to, quote unquote, derive this. Okay, we're trying to find the sines. So trying to find the sines, cosine, tangent of angles bigger than 90 degrees, or pi over 2 radians. Okay. So the way I'm going to show you guys how to do that, Miss White, I just sat in on Miss White's class. She was great at teaching it. I'm not going to teach it the same way as her. I don't like relying too much on memorization in math class. So I'm just going to teach you guys the way I do it. Okay. So I'm going to draw the coordinate axes, okay? Here's my x-axis right here. Here's my y-axis, okay? So do you guys remember from the 4.1 quiz drawing bearings on the coordinates? We did really well on that. Got the coordinate axes right. I think one problem was like sketch a 70-some degree bearing. The other one was like sketch a 135 degree or something like that. Where was 0 degrees on the coordinate axes? Where was 0 degrees?
On the right.
On the right, yep. Positive x-axis. So that's 0 degrees, okay? We're also going to call that 360 degrees, okay? Because when we go counterclockwise all the way around the coordinate axes, that's a 360 degree angle, okay? What is 0 degrees in radians? What's 0 degrees in radians? How do you go from degrees to radians? What do you multiply by? Pi over 180. Yeah, close. That's radians to degrees is 180 over pi. Yeah. So 0 degrees in radians is just 0 radians, okay? So that's 0 degrees, or I'm going to do slash or 0 radians. What's 360 degrees in hey, Mrs. Lincoln? What's 360 degrees in radians?
2 pi.
It's 2 pi, yeah. So we get 360 over 180 pi, and 360 divided by 180 is just 2. Okay? So that's 360 degrees or 2 pi radians, okay? All right. What angle would be here? A quarter of the way around, what would be here? 90 degrees, yep. And what's 90 degrees? I'm going to erase this x and y label because I think we know that, hopefully.
1/2.
Yep. So converting 90 degrees to radians, if we multiply that by pi over 180, we'll get pi over 2. Okay? What about starting from 0 degrees and going halfway around? What angle would be right here? Pi radians, what is that in degrees? 180 degrees. So 180 degrees, or pi radians, okay? And then what about down here? 3/4 of the way around a circle. How many degrees is that? 270 degrees. If we convert that to radians, 270 degrees times pi over 180. This is going to simplify to 3 pi over 2. 3 pi over 2, 3 halves pi, okay? All right. So I just labeled, those are called my quadrantals. It's not super important that you know that word as long as you know those are the angles that are on my axes, okay? And we're going to talk about how to find the sine and cosine of those angles, okay? Right? Because it's not just something you can just look at one of these triangles and see, right? There's no like 180 degree angle on here, okay? So what I'm going to do is I'm going to draw a unit circle, okay? It's called a unit circle because it's a circle whose radius is a single unit, okay? I'm going to draw a circle of radius 1, okay? Radius 1. And I'm going to center it at the origin. All right? It's got a radius equal to 1. And it's centered at the origin, okay? All right. Centered at the origin. Okay? And I'm going to draw, which color should I use? Pink? I'm going to draw this point right here. Let me use a different color. Use light blue. That point right there, okay? I'm going to label it x comma y. It's going to have an x coordinate and a y coordinate, okay? All right? And what I'm also going to do is I'm going to draw another line right here, just another vertical line down to the x-axis, such that it forms a 90 degree angle there, okay? All right. You following so far? So at some point it has an x-coordinate and a y-coordinate, okay? What's the length of the bottom of this right triangle? What would that be equal to? So however far I go to the right from the origin, that's going to be the same as which coordinate here? The x-coordinate. Yeah, it's going to be the same as the x-coordinate, so that's going to have a length of x, right? It's the same x as that x-coordinate there, okay? What's the length of that other side going to be, the vertical leg? However far I go up from the origin, right? That's the y-coordinate. That's my y-coordinate, okay? Okay? And I'm going to take this angle here and label it theta, okay? That's just some angle theta, okay? We don't know exactly what it is, but it's theta, okay? All right. What would the cosine of theta be? Cosine is adjacent over hypotenuse. What's the length of the side adjacent to theta? X, yep. What's the length of the hypotenuse? It's 1. Yep, so cosine theta equals x over 1, or just x, okay? So what's going on here, guys, is the x-coordinate of that point is equal to cosine theta. Okay? So x equals cosine theta. The cosine of an angle, if I draw any angle on this unit circle, its cosine is going to be equal to the x-coordinate of its point on the outer crust of that circle, okay? What's its sine going to be? What's its sine going to be? It's going to be y, yep. So sine theta equals y over 1, or just y, okay? So the y coordinate is going to be equal to the sine of that angle, okay? All right? So we can use our special right triangles, right, for our pi over 4, pi over 6, and pi over 3 angles, okay? But for the rest of them, we've got to use this unit circle, okay? So let's think about this. What point, I'm going to draw a point here. If I have a 0-degree angle, or a 0 radian angle, or likewise a 360-degree angle, or a 2 pi radian angle, okay? What are the x and y coordinates of this point here? If this is a unit circle, if this is radius 1, what are the coordinates of this point? Yeah, so I went to the right one, right, and I didn't go up or down at all. So 1, 0, okay? All right. The quadrantal angles you kind of just have to memorize. So what's the sine of 0 degrees going to be? It's going to be equal to what? Let's keep consulting these guys right here. It's going to be 0, yep. What's the cosine of 0 degrees going to be? 1, yeah. Okay? All right. And that's the same in radians, okay? So sine of 0 degrees is 1. Sine of 360 degrees is going to be what? It's the same point, right? So if I go 360 degrees around this circle, my point is still 1, 0, okay? So the sine's still going to be 0. The cosine's still going to be 0, okay? Or it's still going to be 1, sorry. It's still going to be 1, okay? All right. You doing okay with this so far? Okay. Sine of 360 degrees, let's convert that to radians real quick. That's going to be sine of 2 pi radians, okay? Just the same thing, and this is going to be cosine of 2 pi. And then 0 degrees in radians is just 0. All right. All right, so that's just something, right? You kind of just have to memorize the quadrantal angles, like this, what the sine and cosine at 0 are, or if you can visualize this, you can just visualize the circle and then plot the point. The x-coordinate of that point is your cosine. The y coordinate is your sine, right? Okay. What about tangent? How would we get the tangent? Exactly. So what's the let's go back up to this triangle right here. The tangent of theta, theta's tangent is what? The opposite over the adjacent, right? The opposite side is y. The adjacent side is x. So tan theta equals y over x, okay? Notice how that's the same thing as sine theta over cosine theta, okay? This is going to be really important. Tangent of theta equals sine theta over cosine theta, okay? All right? So what's the tangent? What's the tangent of 0 degrees going to be? How do I find that? It's going to be the sine of 0 degrees right here, 0, over the cosine of 0 degrees, which is 1. Yep. Okay. Similarly, tangent of 360 degrees is going to be equal to 0, which is the same thing as the tangent of 2 pi. Okay. So you guys seeing the reasoning process? All right. All right, and now, so x comma y equals cosine theta comma sine theta. All right. Now, if I have a 90-degree angle, right? A 90-degree angle. Where do I draw that point on the crust? Right here, right? That's 90 degrees. Okay, what's the coordinate of that point? If I have a unit circle, what's the coordinate? Did I go to the left or right at all?
0, 1.
Yep, it's going to be 0, 1. 0, 1, yep. I didn't go to the left or right at all, and I went up 1, right? Because my circle has a radius of 1, okay? So what's, sorry, kind of, let me get rid of this stuff right here. Okay. What's the sine then? What's the sine of 90 degrees? It's the same thing as the sine of pi over 2 radians. What's that going to be? Yep, it's that y coordinate of that point, right? So it's going to be 1. What's the cosine of 90 degrees? Or the same thing as the cosine of pi over 2 radians. That's going to be what here? It's going to be the x coordinate of that point that's on my crust, right? It's going to be 0. Okay. And the tangent of 90 degrees, which is the same thing as the tangent of pi over 2, that's going to be what? What's tangent again? Sine over cosine. So if I put my sine over my cosine here, I get 1 over 0, right? What's that equal to? What do we say? It's undefined. Undefined, okay? All right, it's undefined. Okay. Undefined. How are we feeling so far? Are we lost? Confused? Okay. So you're nodding yes to being lost? Okay. All you have to remember, if I give you an angle, you just have to be able to plot basically that angle's bearing, draw its point on the crust here, and then tell me what its x and y coordinates are at that point, okay? So if I gave you a 180 degree angle, where would I plot that point? A 180, so I'm going to start on the positive x-axis. I'm going to go counterclockwise 180 degrees. So I'm going to flip all the way around right here. So I'm going to draw a point right there, okay? What point is that? If I start, did I go up or down at all to get to this pink point? No. So my y-coordinate is 0. What's my x-coordinate? Where did I go? From the origin to that pink point, where did I go? Yeah, I went to the left 1. Okay? It's a unit circle. So it's going to be -1, comma 0. Okay? All right. So the cosine of 180 degrees, that's going to be the same as the cosine of pi radians. That's going to be equal to what here? What's the x coordinate of that pink point? That x is going to be the same as that x coordinate, -1. Okay? What's the sine of 180 degrees going to be? It's going to be the same as the sine of pi radians. What's that y coordinate there? 0, yep. Yeah. And then tangent of 180 degrees, that's the same thing as the tangent of pi. Right? What do I do for that? What's tangent always equal to? Sine over cosine. Sine over cosine. Okay? So 0 over -1 or just 0, okay? This is all brand new, don't worry too much. It'll click eventually. This is a tough topic. Okay? Okay? And I'll do red down here. Now, right here, down here, okay, if I told you to draw a 270-degree bearing, right, or a 3 pi over 2 radian bearing, right, you'd start right here on the positive x-axis, and you'd go up counterclockwise. You'd sweep around 270 degrees until you came to the bottom down here, okay? So for a 270-degree angle, you're going to draw the point right here because this angle 3/4 of the way around the circle is 270 degrees. So I'm going to put a point right there, okay? What are the coordinates of this point here? What are the coordinates of that point on my unit circle? Did I go left or right at all? No, so I'm going to have an x-coordinate of 0, okay? What's my y-coordinate going to be? I went down 1, so it's going to be -1, yeah? Okay? So we can figure out that the sine of 270 degrees, that's the same thing as the sine of 3 pi over 2. It's just in radians. Let me move this real quick. That's going to be equal to what here? What's my y-coordinate? Yep, so it's always going to be the same as your y-coordinate of that point, okay? The cosine of 270 degrees, that's going to be the same as the cosine of 3 pi over 2, okay? What's that going to be equal to here? What's my x-coordinate? 0, yep. Cosine is always your x-coordinate. Your y-coordinate is always your sine for your angle, okay? Always your sine. Okay? And then what's my tangent? So the tangent of 270 degrees, that's the same thing as the tangent of 3 pi over 2. What's that? That's always what? These 3 yellow things I highlighted, that's pretty much all I need to know to answer my questions. So yeah, so sine over cosine here is going to be -1 over 0. So it's going to be undefined again. Undefined, okay? Yeah. All right. So there's how you get the sines, cosines, and tangents of a 0 or a 360-degree angle, a 90-degree angle, a 180-degree angle, or a 270-degree angle, okay? All right? Now there's other angles we're going to have to find, okay? There's other angles that we're going to have to find sines, cosines, and tangents of, okay? All right? So let's talk about what I want to, what's good though, and the way I want to teach this is for those angles you can still end up using the special right triangles, okay? The sines, cosines, and tangents of all the other angles in these three quadrants, okay? They're all going to have the same absolute values. They're going to have the same absolute values as the sines, cosines, and tangents in our special right triangles, okay? The only difference is some of them are going to be negative, right? Some of them are going to be negative, okay?
Wait, how can it be negative if it's an absolute value?
Like what? So like an angle, like if I said like 5 pi over 3 radians, like 120 degrees, if that's going to have the same like sines and cosines as like a 60-degree angle from this picture. And they'll have the same absolute value. So they'll both be like, one will be like positive root 3 over 2. The other one's going to be negative root 3 over 2. Yeah, you'll see this better when we talk about it, okay? All right? So they'll have the same absolute values. Some are just going to be negative and positive. And let's figure out where, okay? So the x coordinate, so if I'm going around the unit circle, right? If I'm going around the unit circle, okay? And I ask you to find, let's say, let me erase some of this real quick. Let's say I ask you to find the sine and cosine of, let's talk about a 135-degree angle. Where would I draw a 135-degree angle on here? If I start at 0 degrees, and this is 90, which of these two quadrantal angles is 135 right in between? $135 degrees. Is it between 0 and 90? Yeah, it's right between 90 and 180, right? It's right between 90 and 180, okay? Okay? What's going to happen here? Okay? Let's plot that point right there. X comma y. Okay, and I'm going to finish drawing that triangle. Still got a radius of 1, okay? So this angle right here, this is 120 or 135 degrees, okay? Okay? So if I go from 0 degrees to this line right here, I went around 135 degrees. If this is 180 degrees right here, what's this smaller angle that's inside that triangle I just drew? What is that?
45.
It's 45 degrees, yep. It's 45 degrees, yep. Okay? All right, so here's x on the bottom, y on the side. Okay? Let's figure out then the sine of this 135-degree angle. If I drew my ray right here, okay? What's that sine going to be? It's going to be the same as what? It's going to be the same as what? What's the sine of 45? It's going to be the same as the sine of 45 degrees. Okay, what on your guys' sheet, what's the sine of 45 degrees? 1 over root 2, yep. 1 over the square root of 2, okay? What's the cosine of 135 degrees going to be? It's going to be the same as 45 degrees except for one thing. What's the cosine of 45 degrees? 1 over root 2, yep. Yep, but notice, right? What did we say? The cosine is always equal to the x-coordinate, right? In quadrant 2, is my x-coordinate positive or negative? To the left of the origin, is x negative or positive? Negative. So the cosine of 135 degrees is going to be negative 1 over root 2. Okay? All right? It's going to be negative 1 over root 2. Okay? So
Wait, why is it negative?
it's going to be negative because an angle's cosine is always going to be equal to its x-coordinate, and all the x values that are to the left of the origin, on points that are to the left of the origin, are negative. Yeah. So what's going on here, right? So in the first quadrant here, sine and cosine, and those are equal to x and y, those are going to be positive or negative in the first quadrant. If x and y are positive, are sine and cosine going to be negative or positive? They're going to be positive. So sine plus, cosine plus. If tangent is sine over cosine, what kind of number do you have if you divide a positive by a positive? Positive, yeah? So I'm going to put an A here. I'm going to put a big A. I'll do teal. A. That A stands for all of these trig functions, all are positive, okay? All are positive, A, okay? Now I'm going to erase this real quick. If I go to the second quadrant here, okay? What is sine theta? What's this SIGN? Is sine theta going to be positive or negative? If I'm in the second quadrant. If I'm in the second quadrant, am I above or below the origin? Above, right? So my y is positive or negative? So sine theta is going to be positive or negative? Positive, yep. Cosine theta, am I to the left or to the right of the origin? To the left, right? So cosine is going to be what? Negative. And then tangent, if the tangent of theta is sine divided by cosine, so here I'm dividing a positive by negative, what's tangent going to be? Negative, okay? So I'm going to label this quadrant here in the left S, okay? That means that sine theta is the only positive one, okay? Sine theta is the only positive trig function in quadrant 2. In quadrant 2. Okay? Okay? This third quadrant here, sine theta is going to be what? So sine theta is equal to the y value. It's going to have the same sine as your y values. I'm below the origin now, right? I'm below the origin. So sine is going to be negative. Okay? What about cosine? In this third quadrant here, am I to the left or to the right of the origin? So my x values are positive or negative? So cosine is going to be negative. Okay? And tangent. What's tangent going to be here? It's going to be positive, right? Because tangent is equal to sine over cosine. Here, that means I'm dividing a negative by a negative. That gives me a positive. So this third quadrant here, I call this the T quadrant as well, because tangent is positive. Okay? ASTC. Okay? And then what's my only positive trig function going to be in quadrant 4 here? Sine theta is going to be what here? Negative, yep. Cosine is going to be what? Am I to the right or to the left of the origin?
Positive.
Yep, it's going to be positive. And then tangent is going to be what? Sine over cosine. Negative divided by positive. What's that? Negative. Yep, so this is going to be the C quadrant. That's because cosine of theta is positive. It's the only positive one, okay? So the acronym I was taught, if you draw coordinate axes, okay, in this first quadrant, I'll label the quadrants up here. Quadrant 1, 2, 3, 4, okay? All the trig functions are positive in the first quadrant, okay? Only the sine of angles in the second quadrant are positive. Only the tangents of angles in the third quadrant are positive. And only the cosines of angles in the fourth quadrant are positive, okay? All right? So I was taught to remember this by a sexy tiger cat, okay? That's just how I was taught. So all sine, tangent, cosine. Sexy tiger cat. All right? All right, that was what caught on. That was what caught on in our class, okay? So here's how you would do this. Here's how you would, again, Miss White kind of gave it as, they just like built the whole unit circle with like a little like nice arts and crafts activity. I'm not as artsy. God did not give me as many of those gifts, which is great, which is fine. I want to teach this as a method. Okay? So let's go through let's try to get through I don't know, 7 or 8 of these together. If I ask you to find something like, and I'm just gonna draw another unit circle down here because I think there's a little too much going on up here. You guys agree? A little too much. I'm gonna draw it again. Okay. Okay, so let me draw my unit circle. Okay. So again, on the right here, we're going to have 0 degrees, 0 radians. Up here, we're going to have 90 degrees, pi over 2 radians. To the left here, we're going to have 180 degrees, pi radians. At the bottom here, we're going to have 270 degrees, or 3 pi over 2 radians, okay? So what you've got to do here, if I give you something like, if I told you to find the sine of 5 pi over 3, okay? Sine of 5 pi over 3. The first step here is you're going to need to draw a ray for a 5 pi over 3 bearing. Okay? So let's do that together. What is, and you can do this 2 ways. You can convert it to degrees first, or as you get better with radians, you're going to be able to draw it without converting it to degrees. So if I convert 5 pi over 3 radians to degrees, I multiply by 180 over pi. That's going to give me 5 pi over 3. What is that? Is that 120? It's going to be a 300-degree angle, okay? Where do I draw a ray for a 300-degree angle? Where do I draw that? What's that? Cat? Yeah. So if I start at 0 degrees and I go around 300, where am I going to draw on a 300-degree angle? Which quadrant am I going to be in? Yeah, exactly. I'm going to be in the 4th quadrant, okay? All right? So I'm going to be around here, okay? All right? 300-degree angle. Okay? 300-degree angle right there, okay? All right? Step 2 is going to be draw in that right triangle. Draw in a right triangle. Okay. So I'm going to draw this edge, okay, and then a 90-degree angle, okay? All right. And then, how do I want to call this? Let's call that, I'm going to call that theta. This angle right here, the angle that your right triangle forms, with the x-axis is going to be your special triangle analog. That's what I'm going to call that. It's a fancy word, okay? Okay. So if this is a 300-degree angle, so if I start from the origin going all the way around here, this is 300 degrees, okay? This blue angle here is going to be what? If I went all the way around the circle except for that last 60 degrees, this blue angle here is going to be 60, okay? All right? Okay, so it's a 60-degree angle. That's my first triangle analog here, my special triangle analog, okay? We want what? The sine of that angle, all right? So use the special triangle pictures or drawings. Okay. So the sine of for the sine of 300 degrees, I'm actually going to find the sine of 60 degrees. Okay. What is that on your triangle? What's the sine of 60 degrees on your right triangle? Looking at your right triangles, what's the sine of 60 degrees? Yeah, right. So the side across from your 60-degree angle is your root 3. The hypotenuse is 2. So that's going to be root 3 over 2. But I have to, and then the last thing I need to do is make it positive or negative depending on which quadrant you're in, okay? All right? Make it positive or negative depending on which quadrant you're in, okay? So the sine in the fourth quadrant. We're in the fourth quadrant here, okay? Which trig function is positive in the fourth quadrant? Cosine, right? So sine is going to be what? So the sine of 300 degrees, it's going to be just like root 3 over 2, except I have to put a what on it? I've got to put a negative on it, okay? I've got to put a negative on it, okay? This will get better with practice, I promise. Okay? I promise it'll get better with practice. Okay? All right?
Can you leave it there or like zoom all the way out?
Yeah. You guys need to write those steps down? Yeah. Yeah, so we'll take another day on this because I know it's a lot. I know it's a lot to take in. So. No. I did, no, not yet. Okay, so we have 5 minutes left. Let's try to practice another one, okay? Let's try to practice another one. Oh yeah, for sure, yeah. Yeah, so this is the way I've always done it, and it requires less memorization than just memorizing the unit circle. Either way is fine. If this sticks with you, great. If it doesn't, that's also fine. I'm also going to hand out the unit circle.
So we don't need to do the sine cosine.
What's that?
Are we doing the sine cosine?
We can, yeah, we can if you want. The cosine, you just look at your special right triangle and make it positive. Tangent would be look at your special right triangle and make it negative. Okay, let's do the cosine. Can I move on or no? Okay, let's do the cosine. So I'm going to erase a bunch of this stuff. Let's do the cosine of 120 degrees. Which quadrant is my 120, or am I going to draw my line in if I'm doing 120 degrees? It's going to be right here, right? In the second quadrant, okay? It's going to be closer to 90 than 180, okay? All right. So draw in your right triangle. So this is a 120 degree angle right here. Okay. Draw in your right triangle, okay? All right. And then I have to figure out what that special triangle analog is going to be. So what's this angle right here? That's always going to be the angle that my right triangle forms next to the x-axis. What angle is that going to be? Yeah, right, because I went 120 degrees, and then the difference between, to go the rest of the way to 180 degrees, right? This angle is going to be 180 degrees minus 120 degrees, okay? So this orange angle there is going to be 60 degrees. Okay, 60 degrees, okay? Next thing, I'm going to look at my special right triangle. I'm going to write down the cosine of 60 degrees. What is the cosine of 60 degrees? From my special right triangle, what's the cosine of 60 degrees? Cosine of 60 degrees is 1/2, okay? All right. So then what's the cosine of 120 degrees going to be? I just have to change what? Is cosine negative in the second quadrant when I'm in the second quadrant, or is it positive? Negative. Yeah, so cosine of 120 degrees is going to be negative 1/2, okay? All right. So we'll work on this more next time we meet, okay? If we have a snow day tomorrow, I'll probably just give a little practice sheet on these angles, okay? Do we at least start to see how this is done? Okay, good. That's a good start. Good work today, guys.